Economists look at well-being by using utility functions, a functional relationship mapping states of nature to a rank. This kind of preference relation is called ordinal. It is simply the order that matters and not the intrinsic value of the function's output. Different people have different psychological preferences in a society and may value these states on the basis of different things: personal belief systems, possible financial benefit in a state, or alignment to their own goals. But as we know, people don't always make decisions only for themselves. Sometimes the society as a whole comes together to make decisions. Economists capture this in what is called a social welfare function, which is an aggregation of the rankings of everyone in society. Just one common method of aggregation is pairwise majority voting. Now, if everyone voted and these votes were counted under some set of predetermined rules, then one, would society as a whole reach an outcome? And two, if it did, would the outcome truly be democratic? The first question seems quite innocuous at first glance. Why would there not be an outcome? In most cases, there is some kind of outcome of voting, a win, a loss, or a tie. When philosophers and mathematicians formulated voting rules and moved to studying its properties, it turned out that some voting rules led us around in circles instead of giving a definitive social preference ordering. The Condorcet paradox is an infamous example of the running in circles case. In the example of three students just trying to decide which series to read for their book club, there is no conclusive answer of the aggregation process when individual rankings are known to us. Kenneth Arrow, in his PhD thesis written in 1951, took the reverse approach to the problem. Instead of starting from a voting mechanism and trying to derive its nature, he stated some properties he would like a social aggregation mechanism, which he called a constitution, to follow and worked ahead from there. And this brings us to the second question we posed at the beginning of the video. Would the outcome of voting under Arrow's assumptions truly be democratic? I like to divide Arrow's assumptions into three categories on the basis of what they try to achieve in the aggregation process. First, existence. It seems reasonable to assume that the aggregation process actually works for all possible combination of individual preferences and works in a sensible manner. So if everyone in society prefers Lord of the Rings to Dune, then in the social rankings as well, Lord of the Rings must be preferred to Dune. Overcoming paradoxes. Since Arrow's work continued from Condorcet's running in circles example, it makes sense to have assumptions that try to overcome this paradox. The property that social preferences lacked in the Condorcet example was transitivity, and Arrow necessitates social orderings to be complete, reflexive, and transitive. Moreover, for the ranking of an individual to make sense, Arrow introduces an axiom called the independence of irrelevant alternatives, wherein a third unrelated option should not reverse the ranking between two existing options. And finally, for voting to actually make sense, Arrow requires that there is no dictator whose personal preferences become the preference of society. Of course, it is imperative to realize that what Arrow calls axioms are not axioms in the purely mathematical sense of universally true statements, but rather act as prerequisites in his exposition. Now, all these assumptions seem quite sensible individually, but it shockingly turns out that they are incompatible, and there will be a decisive voter, a dictator, whose individual preference and decisiveness over one pair of outcomes determines the entire social preference. And now we move on to the content of this proof. The proof begins by imagining a society with a finite number of voters. Let me denote this number by n. Note that the only restriction on n is that it is greater than 1. We're obviously looking at a society of many people for our result to have any relevance. Now, this result is popularly proven in two steps. One, establishing decisiveness, and two, proving by means of contradiction that all the aforementioned axioms cannot simultaneously hold true. So what is decisiveness? Any individual or a group of individuals is decisive over some pair of outcomes if their preference of one over another, say A over B, ensures that the social welfare function picks A over B, irrespective of all combinations of all other outcomes preferred by everyone else in society, even if the overwhelming majority of the rest don't have the same preference ranking. Now, if an individual person's preference ranking over any arbitrary pair of outcomes or candidates is decisive, then this person is the dictator. Now, Arrow proves his theorem by contradiction. Assume there is no dictator, no decisive individual, and then he follows through with the fairly innocuous assumptions made before and finally shows that the assumption of no dictator cannot simultaneously hold true. So let's keep note of all these assumptions on the top of the screen. That will help us keep track of what is going on. So we need a society where there is no individual dictator. Of course, that does not mean that a group of people cannot be decisive. This might seem like an oligarchy at first, but consider the group of all N voters. If every single one of these voters prefers A to B, then any sensible social welfare function must prefer A to B. That's how fair voting works. Then the set of all N individuals is a decisive set. Depending on what N is, it is plausible that there is some set of individuals with less than n members that is also decisive. For instance, with n equals 10,000, if 9,999 people prefer A to B, society should sensibly prefer A to B. Generalizing this observation, we can say that there is a set of the sets of decisive individuals. One giant set encompassing the set of all people, maybe the set of n minus 1 people, and so on. N is finite, and so the number of decisive subsets we can make should also be finite. And from that, we can reasonably follow that there might be some set of decisive voters that is the smallest in size of all the decisive sets. Of course, there's nothing stopping the smallest set to be n itself if it's the only decisive set, but the fact of the matter is that the smallest set exists by design. Let us call this set S. To be clear, S is a set of a number of individuals less than or equal to n that are decisive over any pair of outcomes. This is not a violation of the no dictator assumption, not yet at least. And so the number of members in S, also called the cardinality of S in set theory, should be more than 1 and less than or equal to n. If all members in this set prefer A to B and everyone else prefers the exact opposite, the social preference will rank A over B. Of course, the way we have set up this proof means that all members in S could be all the n voters and everyone else would be an empty set. Now let us look at this set S in more detail. We know that S has more than one member. The first thing we do is divide this set into two subsets, S1 containing one arbitrary member and S2 containing everyone else from S. Now that we're dividing voters into sets, let's also call the set of everyone not in S, S3. At this point, we have three subsets, S1 with just one person, S2 with everyone in S except the person in S1, S1 plus S2 form the smallest decisive set, and we have S3 which is just everyone else. We have a set of voters, so now let's look at what they're voting about, candidates for outcomes. We'll consider the book club example for further exposition, although these alternatives are really arbitrary. So members in S like Lord of the Rings to Dune, and everyone else likes Dune to Lord of the Rings. S is decisive, which means society as a whole prefers Lord of the Rings to Dune. Now let's introduce a third alternative, Harry Potter, that figures into preferences in a way that maintains the original ranking between Lord of the Rings and Dune for everyone. We can do this because Arrow assumed the independence of irrelevant alternatives. Now, you will notice that the preferences above look quite like those in the Condorcet paradox situation. Society as a whole will still rank Lord of the Rings over Dune. There's no reason for that to change. But society rankings must be complete, and we need to know where the book club will rank Harry Potter. In particular, let us look at how the book club ranks Harry Potter with Dune, and the rest will follow by transitivity. There are three possibilities. Now, society might prefer Harry Potter to Dune, might prefer Dune to Harry Potter, or might be indifferent between both the alternatives. So, what if society preferred Harry Potter to Dune? The only subgroup that has these preferences is S2, which makes it decisive. But we have already established that S2 plus S1 together form the smallest decisive set. So this leaves us with only two other possibilities. Dune being preferred to Harry Potter and the book club being indifferent between the two. We call this a weak preference in social choice theory. Let us now use Arrow's transitivity axiom. Dune is weakly preferred to Harry Potter. Since S was decisive, Lord of the Rings was preferred to Dune. So by transitivity, Lord of the Rings should be preferred to Harry Potter. But wait a minute, we saw just moments ago that S1, the subset with just one member, was the only subset to prefer Lord of the Rings over Harry Potter. And this preference has turned out to be decisive because absolutely no one else has these same preferences. The member in S1 turns out to be a dictator. And this is in direct contradiction to the assumption we started out with, which means that the assumptions must be false, which means that we have a dictator. Now, my reactions when I first learned this proof flitted from delight at its elegance to distress because of its implications, and finally to skepticism. It seemed to me quite unlikely that the voting systems our democracies function on actually depend on one pivotal person somewhere in the middle. There are so many questions about this theorem. What is it about this theorem that causes this impossibility? If there is a dictator, can we identify who the dictator is? The answer to the first question is, as you might have guessed, the assumptions. New alternatives are often not independent. A new point of view can change how people look at current options. An individual might prefer a left government to a center-oriented government. But if a right-oriented government is introduced, they might now prefer a centrist government to the left government, preferring moderation over the possibility of an ideological extreme. Of course, we're not commenting on the correctness of preferences, only the fact that this sort of reversal can occur. And frankly, although this is a violation of Arrow's IIA axiom, it isn't necessarily alien or irrational. Many scholars have also relaxed the transitivity assumption and studied social preferences in such a world. Moreover, our definition of decisiveness at the beginning of the proof assumed strict preferences. It could, however, be plausible that a dictator is indifferent between alternatives, in which case the preferences of others might impact social preference. Moving on to the second question, it seems valid to ask who the dictator is, since we do have one. Now, by the way of the above proof, and in fact most proofs of Arrow's impossibility theorem, the identity of the dictator varies on the basis of the proof technique. In our proof, whoever we separated in S1 would be the dictator. Often, if a large number of people have the same preferences between two candidates or two parties in an election, and if one of them is picked out as a dictator, we don't necessarily end up in an anti-democratic dystopia. And anyway, this hinges on the assumptions Arrow made, which we have learned were not so innocuous after all. Arrow's impossibility theorem has received a lot of scholarly attention, and I'll link some works in the description box below. If you appreciate this video, do drop a like or comment. Until then, thanks for taking out the time to watch this video.